With introductions out of the way, let me jump right in. Here are the topics that I'll cover today. I'll start with a quick introduction to Energy Star. I know most folks on the phone likely have at least a somewhat of a good understanding of what the program is, might be very familiar with it, but I figured a quick refresher might be helpful. Then I'll also share some high-level market data from Energy Star as well. Next, I'll highlight the performance criteria and upcoming specification change for Energy Star air source heat pumps. This change in specification in levels represents a new vision for Energy Star, and so I thought it'd be helpful to talk through a few of the major changes that will be coming up in the near future. I'll then discuss savings potentials for air source heat pumps, both at a national level and in Texas as well. Again, folks on the phone might be familiar with a couple of the studies that I'll be mentioning, but I do think they provide some useful information. So wanted to make sure that folks were aware of those. And then lastly, I'll spend just a few minutes highlighting the way that Energy Star plans to communicate the benefits of air source heat pumps to consumers. The potential studies that I mentioned previously provide some very good insight into how we can communicate the benefits of these products. So I thought while I had the chance, I'd provide just a quick update in terms of what Energy Star is planning to do to help its partners raise awareness of these very efficient products. And then I'll just note, at the end of my presentation, we'll have time for Q&A. So folks want to jot down their questions as I'm going through, I'd be happy to take those. And if they're too technical for me, happy to share with my colleague, Abigail. All right, so first, what is Energy Star? So Energy Star is a voluntary partnership among government, business, consumers, and it is a widely recognized and trusted label. All products that earn the Energy Star are third-party certified, which means basically that a consumer only needs to look for the label to determine if a product is efficient. Manufacturers have clear specifications and testing procedures on how to make their products efficient. And utilities have an easy way to incentivize their products. And actually on the next slide, in just a bit, I'll talk through some of the numbers that show how widely recognized and trusted the Energy Star label is at this point. So what you're seeing here are some top-level numbers from the recently released CEE survey that took a look at a few different key indicators around the Energy Star label. Those indicators include awareness, understanding, and willingness to recommend. So obviously, as you can see, the Energy Star label is highly recognized, well understood, influential. And I just wanted to note this here to essentially note that Energy Star can be an effective tool in campaigns, promotions, utility programs, etc. The label is already used by a number of manufacturers and utilities and other key stakeholders across the country. And essentially, EPA wants to support those efforts through the development of tools and resources to help drive those programs forward. And again, I'll talk a little bit about that towards the end of the presentation. Our goal really is to ensure that stakeholders can leverage the brand to educate consumers. So on this next slide here, I wanted to take just a couple of minutes to provide a quick market overview before I jump into the rest of the presentation. As you can see on this slide, shipments of Energy Star air source heat pumps, both ducted and ductless, so that's what you're looking at there, are on an upward trend. Ductless in particular are on the rise. And we attribute this to a couple of different reasons. One, ductless is starting to drop in price. It's improving in quality and benefiting from increased consumer knowledge around this product category. So we're very interested in working with our manufacturer partners and with others to help continue to drive this awareness forward. And on the next slide, speaking of awareness, I think this is kind of a good way to visually show how that awareness has increased over time. So what you're looking at here is some quick research that we conducted using Google Trends data, and we used the keywords mini split and air source heat pump. So you can see the air source heat pump search trends in red, fairly consistent over time, looking from 2004 to 2020 is the length of time that we looked at here. While mini split is really on the rise. We've seen a big increase in consumers looking for and trying to find more information around this product. They're clearly searching for it. And so what we want to do is make sure that they're finding the right information when they're searching for those products. All right, so with that and the overview of Energy Star, I wanted to dive into the performance criteria for Energy Star certified equipment. And like I mentioned, my focus has been around heat pumps, so that's what I'll focus on here as well. So this first slide, I just wanted to show the current level for Energy Star central ACs and air source heat pumps. So this is version 5 of the specification. And that's the current specification. These levels were set back in 2015. As folks may be aware, DOE is currently in the process of revising federal standards and test procedures for these products. So EPA also undertook the process of updating the Energy Star specifications for these products as well. So what I plan to do on the next few slides is highlight what I think are some of the more significant changes coming up with version 6, the next level for air source heat pumps. So first, I'll apologize for the number of bullets on this slide. I generally try to steer away from text-heavy slides, but I thought it might be helpful to provide a quick summary of the changes that are upcoming with version 6. So let me run through these real quick, and then, like I said, we're going to dive into these in a little bit more detail as we go through the presentation. So first, in terms of timing, the final draft for version 6 is expected to be released this month. So these changes are going to be coming pretty quickly. One big change in particular is that we are going to be recognizing performance for air source heat pumps based on 2 climates. So we'll have a warm and moderate climate criteria and then a cold climate criteria. Some of you may be familiar with NEEP's cold climate heat pump list, or you may not, based on the market that I'm talking to. But there is a lot of interest in this cold climate criteria. So that is something that will be a part of version 6 as we go forward. Version 6 will also specify specific capabilities to facilitate high quality installation. So as you can see in this slide, in order to be certified as Energy Star, the equipment must meet at least 3 of the 6 specified capabilities to facilitate that installation. And we'll go through those details in just a bit. And then lastly, I think the one other item I wanted to note on this slide is that the version 6 specification will use revised metrics, including SEER2, EER2, and HSPF2. And that's based on the new test procedure coming out when DOE revises its levels as well. So here I just wanted to talk about timing a little bit around version 6 and kind of explain why EPA wanted to revise the spec now. Obviously, as I mentioned, there is a new DOE standard coming down the pike that will go into effect in 2023. The other reason being is that version 5 has been effective since 2015. So it's been around for a few years now. Market share was relatively consistent, around 28–29% between 2015 and 2017. And then as you can see on that table there, we started to see an increase in the market share of Energy Star products over the past couple of years. There's also been an increased interest in electrification and cold climate optimized heat pumps, as I mentioned previously, and a consensus has formed around grid services for these products. So in terms of the folks that we generally receive feedback from, the stakeholders that we work with, there was a consensus forming, and so it was a good time to try and incorporate that into the into the spec. So here again, just kind of focusing on timeline and just a couple of items that I wanted to note. You can take a look at these in the 4 bullets kind of towards the bottom of the slide here. One in particular, products are able to certify as version 6 once that specification is finalized. Basically, even though version 5 products won't drop off the list until 2023, manufacturers can start to certify their products as soon as the specification is finalized. And as you can see on that last bullet on this slide, we expect the bulk of version 6 certification to occur around the 2022 timeframe. So here are the items that I wanted to mention in particular in regards to the version 6 specification. I won't spend too much time on this slide. We're actually going to dive into each of these areas in a bit more detail on the upcoming slides. But again, just as a quick summary, in case folks want to refer back to these slides at a later date, these are the 3 that I thought would be important to walk through during our conversation today. So in regards to different climates and different needs, what does that mean for air source heat pumps? So as I mentioned, there will be 2 geographic areas where air source heat pumps can earn the Energy Star label. Although that being said, as you can see in the green text towards the middle of this slide, there is no geographic limit. Basically, programs, contractors, the purchasers of the product basically can decide what each home needs. And then the other factor is that there will be different certification marks, different labeling for each of these products. In terms of the exact description for those labels, that's still in process. We want to make sure that messaging is clear and consistent for consumers. So that is still kind of underway, but certainly much more to come there in the near future. And so, you know, as you can imagine, between cold climate and moderate and hot climate, in cold climate, we wanted to ensure good peak cooling performance, and then excellent seasonal heating performance. So we can take a look at these levels in a few slides from here. But the other factor for cold climate is that we also wanted to maintain performance at low ambient temperatures. So essentially ensuring that coefficient of performance is there at low temperatures, and ensuring that the capacity can be maintained at low temperatures as well, with minimal resistance backup heat needed. So here, as I mentioned, we are going to have different labels. Right now, we're referring to it as cold climate or moderate and hot climate. Again, that might change in the near future, but those are the current phrases that we're using. Manufacturers will ensure that the correct label is on the correct product. But again, that product can be sold anywhere. It'll be up to the purchaser, the installer, to determine which product best meets the needs of the consumer. Which makes things very flexible. You know, it's not up to EPA to decide what climate is most appropriate. It's up to the person that's actually making the installation that can make that decision. So next, the next kind of big item in regards to version 6 that I wanted to highlight were the installation capabilities. And basically, in short, these capabilities help ensure that excellent equipment will be installed well. And so to certify as Energy Star, like I said, the manufacturer needs to provide at least 3 of the following 6 capabilities. Again, with the goal of aiding in that quality installation. So you can see here, you know, the ones that I think are most helpful to take note of: automatic system discovery, so that the system is capable of recognizing compatible communicating devices; airflow measurement, so that the installer can confirm that it is within the manufacturer's recommended settings, refrigerant charge, so that the system can verify, that the measurements are in place, basically. These are aligned with some common standards across the industry, and we feel like these are going to be very helpful both for installers and consumers as well. Again, that feedback facilitates good installation. So from manufacturer, and I'll show these visuals here. So basically from manufacturer to homeowner, we're ensuring that the product is delivering as advertised, that the predicted savings are realized, and that the consumer can remain confident that the high efficient unit that they're purchasing is going to provide the savings that they expect it to. And then the last item that I wanted to note here was around the connected criteria that is being introduced with version 6. This is optional criteria. It's being proposed for inclusion. And speaking of being proposed, one thing that I should note, and I've kind of mentioned this already, but the version 6 spec isn't final just yet. Should be later on this month. So basically all the numbers and values that you're seeing in this presentation could still be considered as proposed levels, and the levels that come out with the final spec are what manufacturers will use going forward. But basically the connected criteria provides both a consumer and utility benefit in terms of demand response, the reporting of energy to the consumer, as well as fault reporting. So this has multiple benefits for, like I said, both consumer and utility as well. So with that, I just wanted to finish in terms of performance criteria. I just finished the last couple of slides here talking about what the levels look like using both the 2023 test method as well as the current test method for both moderate and hot climate and cold climate as well. So what you're seeing here are the levels for moderate and hot climate, again proposed. The spec isn't final just yet, but here, like I said previously, maintaining high SEER and EAR levels in the moderate and hot climate, increasing the efficiency as compared to version 5. And then for cold climate as well, reducing the EAR requirements, but higher seasonal performance factors than the moderate and hot climate. Again, trying to get to the most important components for each of those two climate zones, basically. So I think that wraps it up in terms of performance criteria. And so what I wanted to jump into next was the savings potential around ENERGY STAR HVAC equipment. Again, I'll focus on heat pumps here for the next few slides. I'll start with some quick stats that we at EPA feel are compelling national figures, stats that we use in some of our materials in an effort to raise awareness around these products, and then jump into a couple of potential studies that highlight the savings that these products offer, both nationwide and in Texas as well.
A little on that last section, Dan.
Yeah.
A recommendation on y'all's labeling, a recommendation on the moderate. Oh, you don't have to go back. On the moderate and hot climate, you need a label for, oh my God, it's August in Texas cooling label.
That is a great point. I will pass that on. Thanks, Jason. All right, so like I said, jumping into savings potential. So here, like I said, here are just a couple of the high-level savings statements that we use in some of our resources, some of our materials to try and highlight the benefits of these products to consumers. I'm sure if folks are familiar with the ENERGY STAR tools and resources, you may have seen this already. But basically, to start, First, heating and cooling costs are a big portion of a household's bill. And HVAC equipment in particular is likely one of the more expensive purchases a homeowner is going to make. It may go home, car, and the system that you have to provide AC and heat. And the purchase of that system is obviously not done very frequently. A consumer may purchase a new TV every couple of years, while HVAC is likely every 10 to 15. So we want to make sure that consumers and installers both are armed basically with the best information when they're having those conversations. And then a couple of other items to note. Again, you can see here where we're comparing the air source heat pump to both traditional baseboard heating and oil heat, and then a stat specific to mini splits as well. Again, we saw the rise in consumer searches for those types of products. So we want to make sure that we're providing information specific to the types of products that consumers are searching for. So with that, I will jump into some more detailed information around potential and how air source heat pumps can really help. This visual comes from a study prepared by NREL. The study is a couple of years old, but it provides some very useful information. And we've actually been using it at EPA recently, to understand basically what products offer the most potential for consumers. What are the most cost-effective products where if a consumer makes that change, they're going to see the greatest savings. So this NREL data is very useful. And I thought I would walk through it here a little bit, and then obviously we can talk through it a bit more during Q&A, but if anybody wants to see this study in full, happy to share it as well if you haven't seen it already. Basically what NREL did was that they looked at the efficiency potential in the US single-family detached housing stock market, looking at both technical and the economic potential to inform basically the role that residential efficiency can play. The analysis results identified priorities for residential efficiency projects at multiple levels, national, regional, state, and even getting down into local. And as NREL noted in the report, their analysis essentially used a new approach to this type of large-scale residential modeling. They combined a number of different data sets, both public and private, did a lot of sampling work, simulation work, et cetera. And they also looked at both packages of upgrades as well as individual upgrades. So again, a lot of useful data that came out of the report. And so what this map shows that you're seeing on your screen here is basically the aggregate and the average electricity savings and packages of the most cost-effective upgrades in each home across all categories. So as you can clearly see, there are significant opportunities in Texas, both at that average and the aggregate level. So I'll walk through some more of that NREL data on the next few slides as well. One of the other things that NREL did was, since they had all that great data and broken out by state and by region, they also created fact sheets for each state. So this little graphic here actually comes from the fact sheet that NREL developed for Texas, and essentially shows the potential savings for all cost-effective upgrades in Texas. And NREL also noted that basically 21% of the energy used by Texas single-family homes can be saved through cost-effective changes. And again, what that is saying is that there is a lot of potential out there. And we can actually dive into here what those improvements look like. And like I said, so NREL looked at both packages and individual upgrades. And so what I wanted to show here So NREL ranked the top 10. Obviously, we're only looking at the top 4 here, but the top ranked improvement was that replacement of the electric furnace with the high efficiency heat pump. You can see far and away, it is the most significant in improvement and offers payback in less than 5 years for most households. This was true in most states. That high efficiency heat pump was a significant driver in a number of different states as well. But I think it's very, very important to note here how beneficial these changes can actually be. And one quick item I wanted to note here in case folks are wondering. So the upgrade that NREL looked at was basically the installation of a high efficiency variable speed heat pump. And so the levels that they used in terms of SEER and SPF were a bit higher than the current specification levels for Energy Star, but more in line with the Energy Star most efficient levels. So just in case folks were wondering in terms of what levels they looked at and the types of products, basically they were looking at very high efficiency variable speed products, but they did note in the report that these are products that are available on the market. And they also, one other note from their report, they essentially, these products could be considered cold climate air source heat pumps, but NREL did not consider them as such for their modeling. So essentially their scenario, their modeling includes electric resistance coil for backup heat in parts of the US. Obviously, wouldn't apply likely to what we're looking at here for Texas, but just wanted to point that out in case folks were wondering kind of what the levels were that NREL used. So the other report that I wanted to highlight in terms of potential might be one that folks are familiar with, since obviously it focused on Texas in particular, and that was the PSI Electrification white paper. And so what I dropped in here were some key findings from that document. As many of you know, the PSI report was basically a distillation of the analysis conducted originally by IdeaSmiths. So this is the same data, same information, essentially just kind of distilled down into some key findings and additional information. So, but I thought these key findings were very relevant, very important and useful to share, again, in case anybody had not had a chance to take a look at these. But basically what that white paper found was that shifting from natural gas heating to electric heat pumps has significant potential to reduce not only CO2, but sulfur dioxide and nitrogen oxides as well. And that shift to those heat pumps wouldn't just take away the on-site natural gas combustion and the climate emissions in the winter, but would actually also reduce the summer electricity demand. And then finally, the one other key finding I thought was very valuable is that they ran a number of different scenarios using kind of high efficiency equipment, a more conservative approach where the equipment wasn't quite as efficient, and then a blend of those two. And in all of those, scenarios resulted in cost savings that would be reflected on a customer's utility bills. So, a lot more information in that report. Happy to talk through it in a bit more detail, but I thought those were some very useful findings that came out of that white paper. So with that, as I mentioned previously, these products, air source heat pumps, both ducted and ductless, are really a focus for EPA going forward. And we've been doing a lot of work to develop a number of different resources for these products to raise awareness, generally among consumers, but also among the manufacturers, distributors, and contractors that we're working with as well, to ensure that those conversations that installers are having with their consumers are reflective of the latest and greatest information. Obviously consumers aren't walking into a big box store to purchase an air source heat pump. It's likely that the information that they're getting about these products is coming from their installer. And I know, at least from my perspective, one of the first things I do after a conversation with a contractor is go and look up what they just told me to make sure it's accurate, make sure it's kind of aligns with best practices. So we want to make sure that from the Energy Star perspective, we're providing a lot of that type of information.
I know I share your checklist, your Energy Star checklist for new the Energy Star HVAC installation checklist. I can't remember the exact title of it, but it's part of my packet of resources that I give to attendees.
Oh, that's great.
Of all of my assemblies, because it's a great checklist. Anyway, sorry to interrupt. Keep going.
No, that's fine, Jason. And that's a great point. Again, that is another resource, not one that I was going to highlight here, but that's right. Especially as installation becomes more and more important, those types of quality checklists are very important. And again, with the installation capabilities coming out with version 6, that should also aid in the installation process as well. So, all right. So that being said, and again, I'll try and run through these fairly quickly. I know this isn't really the focus of what we wanted to talk through here, but did want to make sure that folks were aware of some of the resources being developed. And so when we at Energy Star were thinking about the barriers to consumer demand for these products, these are the 3 key barriers that we came up with: complexity and cost, product contractor information, and the awareness from a consumer perspective. And I know we've kind of talked through a couple of these already, so I won't spend too much time diving into how we arrived here, but I'll focus more on the next slide, which is how we are hoping to address some of those barriers. And so basically for that complexity and cost barrier, again, trying to really reduce the complexities for a consumer, what we've done is developed a heating and cooling guide to give consumers, as well as anyone else that's kind of interested in sharing this type of information, access to guidance when replacement might be needed for the system. So you can see a visual of that guide on the screen here. And basically, a consumer can find information about potential symptoms for replacement, guidance around purchase and installation. So Jason, going back to what you just described, this is where something like a checklist is where we could potentially incorporate that information. This tool is live, but we are continuing to refine it, with additional information, especially when version 6 goes live. And then I think the other big factor or kind of component of that heating and cooling guide is the rebate finder. So there are obviously numerous rebates available for these kinds of products. We wanted to make it easy for consumers to find those. So there's information around federal tax credits, as well as rebates available from the consumer's utility as well. Basically, all that they would need to do is drop in their zip code, and the tool will provide information on rebates right from the tool itself. So the consumer doesn't have to kind of jump around to a bunch of different sites to find that information. And then I'll speak to the other 2 on some upcoming slides. So I'll hold off on those for right now. And again, so this is just another visual and some more information around that HVAC guide. You can see it's also on mobile as well. There's a link to the guide on the EnergyStar.gov web pages as well. But again, our goals here were to overcome the barriers to consumer demand. And like I said, the focus is on both ducted and ductless air source heat pumps. And so there are multiple avenues within the tool where a consumer can select which type of product they're looking for, so that they can really drill down and find the right information for those products. Finding information around these products can also be tricky. So what we did was develop a slightly simplified product finder that essentially aims to connect customers to brands and Energy Star certified product lines to facilitate those contractor conversations. So essentially, a consumer can identify that a few different manufacturers make these type of products. In this case, we're looking at Mitsubishi, for example. They can look at rebates in their area, and then they have that information for their conversation with their contractor. Again, because that's likely where the conversation is happening. And then obviously the contractor, the installer, still has access to the CEE AHRI link, which they can then use to filter for the Energy Star information. But that link is certainly geared more towards installers than towards consumers. And then to address that last barrier around the awareness for consumers, I just wanted to quickly highlight here, this was a campaign that was run back in the spring around cooling. But again, we'll have a very similar focus to a campaign that we're planning to run in the fall, upcoming in November. So just about a month's time. And there we're gonna drive traffic to the HVAC guide via Google Display Network ads, and then posts on social media, working with our partners to amplify the message. And essentially try, like I said, to increase awareness. So just wanted to quickly highlight, in the spring here are the impressions, like over 5.7 million impressions from this campaign in the spring, and looking to drive even more traffic as we move into the fall and focus on heating, obviously, as opposed to cooling. And then here are just a couple of additional resources that we have developed. These are fact sheets for both ducted and ductless air source heat pumps. So these are kind of resources available outside of that HVAC guide that I mentioned previously. And, again, available to consumers, but potentially also helpful for folks that are doing trainings and want to learn more either about air source heat pumps or want to kind of share some of the high level, top level information about the benefits of these products to the folks that they're talking with as well. And then lastly, I'll just finish up with a slide on the HVAC campaign that I mentioned that's going to be coming up in the fall. Again, our goal here to overcome some of the barriers that I identified previously. And essentially what we're going towards here is that for steps 1 through 4, basically the consumer is able to do that through the HVAC guide and through conversations with their contractors. So these are the areas that we're hoping to address. And if anybody wants any additional information, either about the campaign or any additional resources that EPA is developing to aid in the raising of awareness around heat pump products, happy to answer those or follow up after the presentation. But I think that takes me through my presentation. So thank you again, everyone, for taking the time. And I'd be happy to take any questions.
Nice job, Dan. And remember, for the inspectors on the call, when a heat pump's installed, one of the mandatory items in the energy code, heat pumps having supplementary electric resistance heat, which they do, shall have controls that prevent the supplemental heat operation when the heat pump can meet the load, which in Texas is 365 days a year, pretty much. I remember I was doing back when I was building official in Granbury, was doing an inspection on an HVAC changeout, and this will make you sick, Dan. So I go and I look, and it's pretty mediocre. I mean, I can tell this guy didn't do a very quality. I mean, it was just, you kind of get that bad vibe. You can just tell by the workmanship. And then I go over to the thermostat, and it's on supplementary heat. And I tell the lady, oh, you don't want to put it on this. I mean, this is a brand new heat pump. You'll be able to handle, your heat pump will be able to handle it anytime. And then she goes, oh, well, the contractor that put it in told me to leave it on that because it'll work better. Like that.
The exact opposite message that we want to be
the exact opposite, right? Yeah, no. I've got a couple of 23-year-old 10-seer trains with propane heat. You think maybe swapping those out with some new Energy Star heat pumps would save me a little money?
I think so. I think so. And I'd be happy. I'd be happy to send you to our savings calculator to show you just how much.
So, well, does it have like a discount coupon with the savings calculator? That's what I need is the ability to afford a new system. Or I know it'll save me plenty of money. So hey, let me ask you I do have a few questions just from my side. Sensible and latent moisture removal in cooling mode. Just some general thoughts around those. I mean, I'm assuming you're going to have sensible and latent, just like in the traditional, or just just talk if you could in general terms about sensible and latent removal for heat pumps.
Yeah, and there I might have to direct you to our very capable technical lead, Abby Dakin, who I mentioned previously. To be honest, I'm not sure that I'd be able to give you a very informed answer there. So I can certainly coordinate with Abby and get back to you on that question, Jason. But that one probably is more up her alley and less so kind of up mine.
Oh, no worries. I just didn't know if you had any thoughts about it. And Abby's email address is on this as well. So those
let me jump down. Yeah, I was just going to say, so for folks that have questions either about kind of that specification, upcoming version 6 that I mentioned previously, or kind of any of those more technical questions that Jason just mentioned there, certainly feel free to either get in touch with me and I can coordinate with Abby, or I did provide her contact information here as well.
And also for the HERS raters on the webinar today, if you missed, we had a presentation over Energy Star and the new HVAC grading, possible getting your builders a bump in their HERS score. That's on our YouTube channel. Encourage everybody to subscribe to our YouTube channel, but we had a real good presentation on Energy Star and HVAC grading a few months back. And that's still available. And we got a couple more. And if you'll just type in your question, we have 133 people on the webinar today. So raising your hand, if you can type your question in the Q&A panel or the chat panel, I'll make sure and Dan answers it. So Benjamin wants to know, how does an Energy Star heat pump compare to running an existing 12-SEER AC paired with a natural gas furnace cost savings? Would you just refer Benjamin to that savings calculator as well on that one, Dan?
Yeah, I certainly wouldn't be able to provide specific figures, but that is kind of the goal around that savings calculator that we've developed. And so essentially with that calculator, you would be able to compare an existing heat pump or an older heat pump. I believe how we've set it up so basically you can kind of go back 5-10 years and compare to older systems as well for both central ACs and air source heat pumps. But obviously the Energy Star version would be more efficient. And that savings calculator would be a great place to start. And again, that is also based on a user inputted zip code. So that would be specific to the climate zone that you're looking for. That calculator basically asks for just a few different inputs from the user, one of them being the zip code, and then obviously the kind of the baseline that you're comparing to, and then that calculator will compare an Energy Star and the Energy Star most efficient product to the baseline that you can enter via the calculator as well.
Okay, and this one's pretty technical, but Tim asks, and I'll take a shot at answering it first, and you can have a shot afterwards, Dan, or refer him to Abby as well. Tim wants to know, do you find programmable thermostats and designing the manual J load conflict with one another? Thinking of supplemental resistance heat when set point is automatically raised. That to me is not a non-issue. I'm not 100% thinking of supplemental resistance heat when set point. I don't think that wouldn't mess with your manual J and designing the manual J. That wouldn't mess with your load calculations one iota, Tim. That I don't think that's an answer. Do you have anything to add to that one?
No, I don't, Jason, and I'll defer to you. But I think if I understand the question correctly, I think I would agree with you as well.
Yeah, and we do have coming up at the end of the month, I've got Gil Rossmiller with Colorado Code Consulting. He's doing, we've got brand new webinars coming up for you on manual JS&D. I know we've been doing a lot of that lately, but Gil has a little bit of a different approach, and I really like his style. So I hope you could, everyone, you'll be getting invitations for those webinars probably late next week. I'll go ahead and send those out. Nancy down in Laredo, how you doing? Nancy wants to know, does the calculator take into account microclimates? So I'm assuming if you type in your zip code, you're not going to have more than one climate in one zip code. So if it takes into account zip code, it de facto takes into account microclimates. Is that a decent answer?
Yes, I would. Yes, I think that's a good answer.
Okay. Well, that's all the questions. Wow, we're giving people an extra 11 minutes of their day. I'm going to go ahead and just recommend everybody go ahead and take the rest of the day off. Let your boss know I said that was okay. Can you write a detailed drawing of the insulation? Okay, Sally asked the source of weather data on the calculator. I'm assuming that's the same ASHP weather data. And with the copy of that you'll get of the slides today, you'll also get a basic mechanical code guideline Word document that I send out after all the HVAC related presentations. And on that basic mechanical code guideline, there is a hyperlink to the weather data. And I would be willing to wager almost anything that DOE is using the same weather data as ASHRAE. So there's a free link to that, and that will be included. I'm not sure what a detailed drawing of the insulation means, Michael. Shoot me an email, Michael, and I will get to the bottom of that question for you. Well, that's it. I'm going to go ahead and let everybody take the rest of the day off. Dan, thanks so much. You did a great job. I know I just recently bought a new clothes dryer, and one of the deciding factors was it had the Energy Star logo on it.
Fantastic.
You know, the marketing and branding of Energy Star. I mean, I haven't certainly done them. Oh, my boss is on the webinar and he says, keep on working. If I would have known he was on the webinar, I wouldn't have told y'all to take the rest of the day off. So I take that back. Be like me and go ahead and work hard for the rest of the day. That's what I'm doing. I promise I'm not going to go out in the backyard and work on my cantina bar. Promise.
Well, Jason, if it works in reverse, you can tell your boss that I said to take the rest of the day off.
Oh, there you go. It does. Thank you, Dan. I appreciate that. Does work in reverse. That I have now been cleared to take is it okay if I go out in the backyard? I'm building a cantina bar in my backyard. Is that okay to go ahead and work on that?
I think that's a very good use of your time.
Fantastic. Thanks, Dan. Thanks, everyone, for joining us. Thanks, Dan, for presenting. Great presentation. Just a reminder, you will get a copy of a PDF of the presentation, my mechanical code guideline, and a course evaluation for ICC CEUs. A couple of thank yous and great presentations have come in. So thank you, everybody, and have a great day. Thanks again, Dan.
Thanks, everyone. Thank you, Jason. Take care.
Bye-bye.